Electricity feels invisible until the monthly bill arrives. Then suddenly it becomes very real. For many households, power costs have slowly increased over the years. Appliances are everywhere: refrigerators, air conditioners, chargers, computers, lighting, and dozens of devices that run quietly in the background. Each one uses a small amount of energy, but together they add up. Because of this, many people begin searching for ways to reduce their dependence on the electrical grid. One idea that often appears is the DIY generator. The concept seems simple. If you could generate even a small amount of your own electricity at home, you might reduce the amount of power you need to buy from the utility company. But can a small homemade generator actually make a meaningful difference? To answer that question, it helps to understand how electricity is normally produced. Most large power plants use massive rotating turbines. Water, steam, wind, or fuel creates motion, and that motion spins a generator. Inside the generator, magnetic fields move past coils of copper wire. When this happens, electrons begin moving through the wire, creating electrical current. This process is known as electromagnetic induction. It is the same physical principle used in nearly every generator in the world. What makes power plants different is scale. Their turbines are enormous, and they operate continuously. That allows them to generate large amounts of electricity. A DIY generator follows the same basic idea, but on a much smaller level. Instead of a giant turbine, a small generator might use a rotating disc or shaft. Instead of large industrial coils, it might use copper magnet wire wound into a compact coil. Instead of huge magnetic assemblies, it might use several strong permanent magnets. When the magnets move near the coil, the magnetic field changes. That change forces electrons in the copper wire to move. As a result, electrical current appears in the circuit. In other words, motion becomes electricity. The interesting part is that the components required to build a small generator are surprisingly simple. Copper magnet wire is widely available. Permanent magnets, especially neodymium magnets, are inexpensive and easy to find. A rotating mechanism can be built using a small shaft, a hand crank, or even a low-speed motor. Basic electronics like diodes or rectifiers can help convert the electrical output into a form that is easier to use. Many small generator experiments can be assembled on a workbench using common tools. The coil is usually wound around a small form so that the loops of wire remain organized and tightly packed. The magnets are mounted on a rotating surface, often a disc or rotor. As the rotor spins, the magnets pass close to the coil repeatedly. Each pass causes the magnetic field through the coil to change, producing a small pulse of electricity. These pulses combine to form a usable electrical signal. Often the output is alternating current, because the magnetic field changes direction as the magnets rotate. If the electricity needs to charge a battery or power certain devices, a rectifier circuit can convert the alternating signal into direct current. At this point, the system begins to resemble a miniature version of a real power generator. But the important question remains, can this type of system actually reduce a power bill? The honest answer depends on several factors. A small DIY generator will not produce the same level of electricity as a power plant. Its output is limited by the size of the magnets, the number of turns in the coil, and the speed of the rotation. However, small generators can still serve useful purposes. They can charge batteries, they can power small electronic devices, they can support lighting systems or low-energy equipment. If a generator provides even a small portion of the electricity used in a home, that energy does not need to come from the grid. Over time, small contributions can add up. Another advantage is flexibility. A DIY generator can be powered by different forms of motion. Some people use hand cranks for demonstration purposes, others connect generators to small wind turbines. Some systems are driven by water flow in small streams or gravity-fed water systems. In certain cases, generators are connected to pedal systems or mechanical equipment that already produces motion. Each of these approaches converts existing motion into electrical energy. This idea is important. A generator does not create energy from nothing. It converts energy from one form into another. Mechanical motion becomes electrical current. Understanding this conversion process is one of the most valuable lessons a small generator can provide. Once people see how magnets, coils, and motion interact, electricity becomes much easier to understand. It stops feeling like a mysterious resource that only comes from distant power plants. Instead, it becomes a physical process that can be observed directly. This is the key insight behind many small energy projects. They reveal how energy systems actually work. A DIY generator may not replace the electrical grid, but it can reduce reliance on it in small ways. It can provide backup energy for specific devices. It can support battery charging systems, and it can help people better understand how electricity is produced and managed. When people begin experimenting with small generators, they often start noticing other opportunities for efficiency as well. They begin paying attention to how much power devices consume, they look for ways to reduce waste, they explore other forms of small-scale energy production. In many cases, the generator becomes the first step toward a broader understanding of home energy systems. The most important takeaway is that electricity generation is not magic. It is a system built on clear physical principles. Magnetic fields move, coils interact with those fields. Electrons begin to flow, energy changes form. Once that chain becomes visible, the entire concept of electricity becomes easier to understand, and when people understand a system, they can begin improving it. Small improvements in energy awareness often lead to smarter decisions about appliances, efficiency, and energy use. A DIY generator is not a miracle solution, but it is a practical tool for learning how energy moves through a system and how small amounts of power can be produced locally. If you enjoy learning how practical energy systems work and how simple experiments can reveal the principles behind modern electricity, consider subscribing to the channel. New videos break down real engineering ideas in clear and simple language. You can also check the description for a helpful resource that explains some of the components people often use when building small generator systems and similar hands-on energy projects.